In this video, I want to just do two more examples that utilize the chain rule. One is a different kind of chain rule, and the other one is a more theoretical approach. Let's start with a different kind of chain rule. It's not always going to be exponents. Here, what is our inside function? What's on the inside now is x squared plus 5. That's going to be our u. So then y is e to the u, right? If u is that inside function, what's left over? E to the u. And we know that u is going to be x squared plus 5. Now the chain rule tells us that dy dx is dy du times du dx. What's the derivative of y with respect to u? What's the derivative of y where u is our variable? The derivative of an exponential function is itself. Now, we couldn't just say the derivative of this exponential function was itself, because there's a lot more going on in here. The property is only when the exponent is just a variable. If there's ever anything else up here, much more complicated. Okay, so we do need to use the chain rule here. It's not the derivative of anything on top of an e is itself. It's only e to the x or e to the t or e to the u, e to some variable. Now what's the derivative of u with respect to x? That's going to be 2x. All that's left is putting everything in terms of the original variable. U is x squared plus 5. And then here it's usually normal to put the 2x in front. And we'll get this as our answer. This is our derivative. If you're using the Newton notation, what you'd do is you'd say y prime is the derivative of the outside function, and the derivative of an exponential function is itself, multiplied by the derivative of the inside function, which is just 2x plus 0. That's another way to get to the same answer, but it's a little bit more confusing to see where this comes from. I think this notation and framework over here is a lot more clear. But either method works. Example 12. Gosh, we're really got a lot of examples. I don't know if anyone's noticed, but this section's a little long. The table gives values for a few functions at a few different points. Use these values to determine f of g. Remember what this means right here? This means f of g of x. That's what that circle means. It's function composition. It means g is on the inside. And the derivative of f of g of x at -1 and at 0. So we don't care about anything in these spaces, right? We only want the function composition when x is -1 and when x is 0. And in fact, my guess is we can't even find these other ones, but I don't actually know. I haven't looked that far ahead, but I don't think we'd be able to find them at all. So what is f of g at -1? What goes here? Well, f of g of -1, let's remember your precalculus. That's f of g of -1. That's the definition. If you've seen this before, I don't think I talked about it much in my precalculus class, but that's the definition here. So if you haven't seen it, here it is. That's what it means. And now we start with the inside. What is g of -1? Well, here's different values of g. This is the value of g when x is -1, right? It's the intersection of x is -1, and these are g. The intersection is 3. So if g of -1 is 3, then simplifying that looks like this. G of -1 is 3, so just replace it. What is f of 3? Here's the values of f when x is 3. F of 3 is 0. We're going to get that this is 0. That's our conclusion here. Okay. Now you can do something similar with when x is 0. Try it. Pause the video. Try to fill in this spot right here. See if we get the same thing. This is f of g of 0. Again, we have to figure out, well, what is g of 0? We go over here and find that when x is 0, g is 1. So over here, we're now left with f of 1. And we can find out that f of 1 is 1. When x is 1, f is also 1. And that'll be our value here. Also, I typed this wrong. This column should say f of g prime at x. That's what this column should say. Sorry about that. Update that on your notes. I don't care about g of f. So we also want to know, okay, what is the derivative of f of g at 1? Well, that's the derivative of f of g. What does the chain rule say this derivative is? Also, again, remember what I said earlier. We do need to take the derivative first before plugging in. The chain rule says this is the derivative of the outside function. We leave the inside alone and then multiply by the derivative of the inside function. This is literally, if I can find it, literally what the chain rule says. So now, again, we do something very similar. This is f prime of, again, we want to know what is f of g prime at 1? Well, we need to know what is g of 1. And then we'll multiply by g prime of 1, and we can find all these things. G of 1, the function value of g when the input is 1. G of 1 is 0. So we now have f prime of 0 times, oh, well, what's g prime of 1? We know that. G prime, when our input is 1, is 3. Great, now we're getting very close. F prime of 0, when x is 0, f prime is 3. Times this 3 from over here. We're going to get this value is 9. Lots of hoops to jump through, but gives us some good practice with this notation. All right. Next up, we need to find f of g prime when x is 0. So we're going to do something very similar. F of g prime when x is 0. Same thing as before. Try to do this on your own. G of 0, we need to find what that is. G of 0 is going to be 1. So now we have f prime at 1 times, well, what was g prime of 0? G prime at 0 was 2. Oh dear. I just noticed over here, I did it for 1, not -1. We were supposed to evaluate it at -1. What I really did is they found that this was 9. I'm not going to go back and fix it. But yeah, just to be very clear that I did answer the wrong part of the question. All right, g prime of 0 was 2. Great. So we get something that looks like this. All that's left is to find out what f prime of 1 was. F prime at 1 was -1. We get -1 times 2, or -2. You could do something similar to find what the question actually asked. That box up there. But that's the idea here. Okay? That's what it wants us to kind of do. What is f of g? It's function composition. Looks like this. We also can find the derivative using the chain rule. There's no real other way of doing the derivative other than the chain rule. This one won't pop up that much, but it will pop up a little bit. This is the more important one for this video, okay? Let me know if you have any questions, and have a good one. Bye-bye.